In the southern hemisphere, there are three significant zones of airflow convergence, giving rise to convective cloud bands that extend southeastwards from heat sources in Brazil, the South Atlantic Convergence Zone, over Indonesia, and the Pacific Warm Pole. The South Pacific Convergence Zone (SPCZ), and in Central Africa, the South Indian Ocean Convergence Zone, all in the austere summer. The SPCZ, which has been most studied, involves the southern hemisphere ITCZ in its tropical section west of 180 degrees longitude, and wave disturbances on the South Pacific polar front along its extratropical section. The cloud band extends to 25 degrees south, 150 degrees west, according to Vincent. The other two do not have extratropical elements and are only linked to the continental heat sources. Their formation and maintenance are poorly understood. They weaken and disappear in winter as the subtropical high-pressure cells shift equatorward over subpolar oceans in both hemispheres. There is a distinctive type of weather system known as the polar low. These have a diameter of only 500 to 1,000 kilometers and a lifetime of a couple of days. They typically form near the sea ice margin, where there are steep temperature gradients, and beneath an upper cold low. They span up to 12 to 18 hours. One type as a spiral pattern of circumnimbus clouds around an eye, analogous to the tropical cyclone. The other is a cloud system shaped like a large comet, known as comet cloud. The former tend to occur in polar air, the latter nearer to the polar front. They bring severe weather with snow and hail and winds of 20 to 30 meters per second. They dissipate rapidly when they move onshore. They occur during November-March in the northern hemisphere and year-round in the Southern Ocean. Marine stratocumulus cloud decks commonly occur in the subtropical latitudes of the west coast of the major continents related to the cold ocean currents noted above. The cold decks over the eastern North and South Pacific and the eastern South Atlantic are well-known examples because they often affect the west coast strip of their respective continents. The eastern North Atlantic typically has less extensive cloud cover as water temperatures there are somewhat higher downstream of the zones of stratiform cloud. To the west, skies are nearly clear, with scattered cumulus cloud formed in the trade winds flows, typically aligned in cloud streets parallel to the wind direction. Subsiding air in the subtropical anticyclones gives rise to a trade wind inversion of temperature, and this limits the vertical development of the clouds. Further downwind over the central oceans, the subsidence weakens and cloud tops penetrate the inversion, gradually spreading moisture upward. Also, cloud clusters and traveling waves from along the ITCZ in the Caribbean. Traveling waves, known as easterly waves, are common during April to May, October to November. They were first described by Herbert Riehl in the 1940s. There are about 2 systems per week traveling eastward at 20 to 35 kilometers per hour. The waves are 2,000 to 2,500 kilometers long and consist of an open waveform extending northward from the equatorial trough of low pressure ahead of the wave, there is a divergence at low level and a subsidence giving little cloud. Whereas behind the wave, there is low level convergence that gives rise to convection and a rainfall. Eventually, over the warm waters of the eastern oceans, some of these disturbances may develop into tropical storms and hurricanes. In a similar fashion, there are waves and shallow depressions in the central and western Pacific, some of which developed into tropical storms and typhoons. Areas of deep convective activity in the western equatorial Pacific Ocean exhibit a quasi-periodic behavior reoccurring over about 7 to 21-day intervals. The system drifts slowly eastward from 140 degrees east to 180 degrees east. Herbert Riehl was born in Germany in 1915. In 1933, his mother sent him to England to perfect his English. He immigrated to the United States in 1933. During the 1940s, he worked at the Institute of the Tropical Meteorology in Puerto Rico, where he provided a description of the easterly wave. In 1954, he wrote the first classic text on tropical meteorology and lectured on it at the University of Chicago. He carried out studies of tropical convection with daughter Joanne Simpson and they developed the concept of hot towers, deep cumulonimbus that transport heat into the upper troposphere. He became known as the father of tropical meteorology. He moved to Fort Collins, Colorado in 1962 to begin the Department of Atmospheric Science at Colorado State University, from where he worked on the meteorology of Venezuela. Tropical cyclones. Tropical cyclones form from pre-existing tropical waves or depression that move out of Western Africa or redevelopment in the Eastern Pacific after crossing Central America. Those in the Northwest Pacific developed from tropical waves and depressions in the Central Pacific. The waves in West Africa have a wavelength of about 3,500 kilometers and occur about every 4 to 5 days from June to early October. The cyclones are known as hurricanes in the West-North Atlantic, typhoons in the Northwest Pacific, and cyclones in the southwestern Indian Ocean. Their development takes place over warm surface waters, where temperatures are greater than 27 degrees Celsius. Most form over waters between 28 and 30 degrees Celsius as a consequence of the absence of such high temperatures in the South Atlantic. Only one tropical cyclone has ever been recorded there. North Hemisphere cyclones typically move westward within the tropical easterlies and then recurve northward and south and northeastward over eastern North American and Eastern Asia as they are steered by the upper southwesterly winds. However, some Atlantic systems enter the Caribbean and Gulf of Mexico. A few of these cross Central America and redeveloped in the Northeast Pacific of Mexico. Cyclones in the Southwest Pacific curve northwestward towards northeastern Australia, while those in the Southwest Indian Ocean curve southeastward toward Madagascar. Systems in the Bay of Bengal, which originate from westward moving depressions in the tropical easterlies, impact Bangladesh and eastern India. Occasionally, a system forms in the Arabian Sea. Here summarize the mean and annual frequency of tropical storms and cyclones in the major ocean basins. Land. So land occupies 39% of the northern hemisphere and 19% of the southern hemisphere. The average elevation is only 840 meters. The climates of land areas are determined by many factors: latitude, distance from the ocean, mountain ranges, vegetation, and snow cover, and synoptic weather patterns. Latitude has major effects on incoming solar radiation amounts, which decrease in winter to zero at the Arctic Circle. In summer, radiation receipts are less variable with latitude owing to the increase in day length, with latitude offsetting the low solar elevation angle. Annual temperatures decrease with latitude. They vary diurnally in low latitudes and annually in high latitudes as a result of the diurnal and annual cycles of solar radiation and daylight. At the equator, the day length is close to 12 hours year-round. At the poles, the sun is above or below the horizon for 6 months for the year, and there is almost no diurnal temperature variation. So for prevailing winds, distance from ocean in the direction of prevailing winds exerts a major influence on the annual temperature range. Near the coast, this range is small, but it increases rapidly as one moves inland. Annual temperature range from July to January means is used as a measure of continentality, which is largest in the continental interiors. The highest mean annual temperature range is an astonishing 16 degrees Celsius in northeast Siberia and greater 40 degrees Celsius in the Yukon of northeast Canada. In contrast, it is only 10 to 15 degrees Celsius in maritime coastal regions in middle latitudes. There are similar small ranges in tropical latitudes due to the contrast almost overhead sun, with increasing distance from the upwind ocean, precipitation amounts decreases and cloud bases rise in response to the drying out of the air as a result of rainfall. In Europe, annual precipitation amounts decrease from 500 to 700 millimeters in north-central France to 300 to 500 millimeters in north-central Poland and in Ukraine. For example, the drop-off in rainfall amounts moving eastward in mid-latitudes is greatly strengthened by the presence of mountain ranges along the west coasts of North and South America, Northwest Europe, and New Zealand. Mountain summits may receive around 4 times the amount that falls upwind, and on the lee side there is a rain shadow where totals may decrease to only 1/4 to 1/3 of the upwind amount. In Western Scotland, at sea level, annual totals are around 1250 millimeter, and this decreases to less than 600 millimeter in the western part of the country. In the South Island of New Zealand, annual totals exceed 10 meters on the west slopes of the Southern Alps and decline to below 700 millimeter east of the mountains. Vegetation cover affects climate through its albedo, evapotranspiration, and surface roughness. The albedo ranges from 0.01 over forest to 0.05 over grassland, hence causing greater absorbed solar radiation over forests. The evaporative responsive is shown to be very important in heat wave conditions. Tower measurements in Europe shown that initially surface sensible heating is 2 to 4 times higher over forest than over grassland, according to